this is related to our before starting the uh, today's topic. Uh, let me give you like a brief recap of uh, the first class so that we can connect the dots. So in our first class, what we studied that what are the basic element of the mechatronic system. So in mechatronic system, first we have a information system, then mechanical, electrical, electronic, like that. We have different systems. Hello. So coming to the information system, is there any problem? Yeah. Hello.
Yes, sir.
Kalyan, some voice issue is there or is it clear?
It is clear.
Because I am hearing some. So, so coming to this mechatronic system, so if you concentrate on a information system, so basically our information system consists of simulation and modeling, automatic control and optimization. So if you talk about this modeling and simulation system, so basically what we have covered that it's a representation of a working system. Yeah, I am hearing some issue.
No, sir.
Yeah.
Sir,
So
I think you have given controls to all participant, I guess. Like they can
yes,
mute anybody.
that's the problem. That's the problem I am facing. So we have to manage, or shall I send another link of my personal room where you can join like that? Because every time I need to, uh, this notification is coming in and I have to make somebody to join. Can we do that, Kalyan?
Yes, sir, we can do that.
Yeah, yeah, it will be. So let me share my personal room. So please join on this personal room. Okay. Kalyan?
Hello, sir.
Kalyan, you can share this personal room link. In chat
Yes.
box, you can see.
We can't see chat box. I can't see.
So you joined from your personal ID, Kalyan.
Yes, sir. I joined from personal ID.
Can you see now? No? Wait.
No, sir. I didn't get any. Can you share in WhatsApp or mail?
Yeah, I'll do that. I'll do that. Your is 23B now. Let me share.
Oh,
That group email ID is MEC 2023.
yeah, MEC 2023.
Yeah. So I have sent there, so you can join that link. Huh?
Yes, sir.
Okay.
Yes, sir.
Because I'm not finding that option also to allow automatically. Uh, Amarnath,
Yes, sir.
uh, see, I have given you co-host, right? And I'm also giving co-host to Kalyan. Check whether you can allow others to join the meeting.
Yes, sir. Checking, sir.
Yes, sir. We can allow them. We
Yeah.
got
So
the.
kindly allow them. We'll start. Huh?
Okay.
Yeah. So I think my screen is visible now. Okay. So as I was telling you that in a mechatronic system design, the modeling and simulation is one of the most important criteria. So we have to uh, understand first what are the basic system. What are the basic system models? Okay. So if you, as I was telling you that in order to develop any mechatronic system, we have to first design a model, and a model is a replica of a sorry, closed replica of a real-time system. Okay. So so why? So it should be a closed replica in order to study the behavior of the real-time system. So in order to assess the behavior of any real-time system, a model is generally expressed in terms of mathematical equations or models. Okay. So basically, a mathematical model will be a relationship between output of the system and the input. Means let O be the output. So output will be a function of input. Okay. So this relationship will help you to predict the behavior of system, behavior of system. So output can be in terms of force, okay, okay, or any other parameter, let's say like strength of the system, okay. And input, if you are considering a force, so input can be acceleration, velocity, mass, okay. So we have to develop a mathematical equation which are the close representation of any real-time system in order to predict the behavior of a system such that the output is the function of input, okay. So let's say you consider a spring system, so where the output force is represented as F is equal to kx, okay, where x is the displacement, okay, k is constant. So this is a mathematical representation of a mechanical system which is defined by a spring, okay. So although it's a mathematical model which is representing the input and output relationship, but we are considering this model with some assumptions, okay, with some assumption, because if the force increases higher than the yield strength of the spring, then what will happen? There will be a permanent deformation, okay. Also the force should not be higher than the UTS of the spring, otherwise it will result in the failure. So this model F is equal to kx, okay. So when F should be less than ys, okay, that is a yield strength. So these are the assumptions we have to consider, okay. So in order to design any mechatronic system, we have to develop a system model. And if you consider any mechatronic system, so it consists of different type of system model, which will be a mechanical system, it consists of a electrical system, it consists of a thermal or fluid system. So these are the four systems which combine together result in the mechatronic system, or a combination of these four will result in the development of a mechatronic system, okay. So these are the basic building blocks, what we call them as a basic building blocks of mechatronic system, and combined together or combination of this will result in a development of your mechatronic system. So itself, if you consider a electrical system, it has certain building blocks like capacitor, you can have resistor, you can have inductor, okay. So these are the three basic building blocks which will develop a electrical system or a circuit, and each of this building block is represented by uh, individual properties. Like capacitor is defined by its capacitance, resistor is defined with the help of this property called resistance, and likewise inductance, okay. So these all uh, four above mentioned mechanic systems itself has certain building block which can be combined together to develop a system, okay, an individual system, okay, and this individual system combined together result in the formation of a mechatronic system, okay. So let's say you have electrical, mechanical, fluid, thermal. So itself it is having some building blocks. Here also we have some building blocks, And using these building blocks and system, you can develop a mechatronic system. So when you come to this building blocks, each building block is represented by certain mathematical equation, and with the help of this equation we develop a mathematical model. Okay, so so if you consider this electrical system, by combining this all three, that is capacitance, resistance and inductance, you develop, let's say here, input output relationship is y1 is equal to fx1. For capacitor, yr is equal to fxr and yi is equal to fxi. So all these three output, this is for your understanding purpose. Okay, it's not like that, just for understanding you can think of it. Okay, so combining this basic building block, that is capacitance, resistance and inductance, you have developed a electrical system which will be the combination of this, all the outputs and input all together. And this type of system are termed as lumped parameter system, where each property or function is considered independently. If you consider this function y1 and fx1, these are considered independently. These are coming from your capacitance. Okay, likewise fx2 and yr are considered individually while developing a building block using resistance, likewise your inductance. Okay, so in line to this, we will be covering our different system model. First, we will be covering our mechanical system building blocks. Okay, a mechanical system building block. Okay, so in a mechanical system, you have generally three building blocks. One is spring, a dashpot, oblique damper. Likewise, you have a mass element. So these are the three building blocks of a mechanical system. Okay, if you consider your spring represent stiffness of the system. A dashpot or damper represent forces opposing the motion, and a mass generally represent resistance to acceleration. Okay, so in any of this mechanical system, you have a building block, spring, dashpot and mass, which are the representation of stiffness, friction and inertia. So basically, any of you take any mechanical system, a mechanical system must have element which represent, a mechanical system must have a building block which represent stiffness, which represent friction, which represent inertia. So there is no strict or hard and fast rule that your system should have spring, damper or a mass element, but your system must have these representers, means your system must have this representer of the properties, that is stiffness, inertia and friction. Okay, so combining the element which represent this property, you can develop a mechanical system. So if you consider your piston cylinder assembly, okay, so you have a mass element in terms of a piston. Okay, you have resistance by your side wall of the cylinder and also the fluid element. Okay, and sorry, the fluid element will act as the damper. Okay, and you have stiffness element in terms of the uh, building block in terms of the material resistance offered by the piston and cylinder. Likewise, if you consider your spring and mass element, so you have all of these three element which is kept on the surface. You can have friction, you have inertia, and you have stiffness. So these element, the element should be considered which represent these three basic properties. Okay, so first we will be considering our spring element. So a spring element basically represent stiffness. Okay, and stiffness is defined as the relationship between force, okay, which is used to extend or compress the spring, which is used to extend or compress the spring. Okay, so stiffness is the basically represent the relationship between force, which is used to extend, represent used to extend or compress the spring. Okay, and this resulting compression and extension is defined in terms of x. Okay, so basically what you have, force is directly proportional to this x, or F is equal to kx, and F is your spring constant. So higher this k, more stiffness will be offered by the spring and higher force is required. Okay, so basically if you represent here, so you have a spring which is a tension force F is applied, which will result in a displacement of x. Okay, so your, if you develop a simple building block, so you have a spring and input is given in terms of force, that is your input, and finally the output you are getting in terms of x. Okay, likewise you have a dashpot or a damper, so it basically resists the motion. So you have a frictional element here. Okay, frictional element. So basically a dashpot represents the damping force. So damping force basically resist or slow down the moving object. So in case of a piston cylinder assembly, you have force here. Okay, so let's say you are applying a force F here, so it will result in the movement of this piston, which is restricted by this movement of piston inward is resisted by the fluid. Okay, so fluid itself offer a resistance. Okay, so it is acting as a damping element. So if you have a dashpot F, so F is the input and you are getting motion. If you are talking about, so in terms of velocity you can represent, and F is equal to CV, where V is velocity and C is the damping constant here, and this F is equal to C dx by dt. Okay, next, that is your third element, which is your mass, which is a inertial component. Okay, so you have simple relationship between force and mass, that is F is equal to ma. Okay, and F is equal to m dx square by dt square. Okay, if you talk about the energy, so if you consider a spring element, so energy is given as half kx square. So this is the stored energy of the spring. If you talk about your mass element, so energy is stored in form of Ke, that is half mv square. If you talk about your dashpot element, there is, instead of storing the energy, here it generally disappears. Okay, it generally disappears because whenever a friction is involved, okay, so dissipation of energy take place in form of heat. Okay, so the two element, that is spring or inertial element, that is mass, they are generally represent storing energy. However, a dashpot represent dissipation of energy, which is represented by P, which is equal to CV square. Okay. Next is your uh, rotational system. So if you talk about your mechanical system, first you have uh, a system where your linear motion is involved. So you have spring, dashpot, and mass. Also, you have a rotational component, or rotational forces are also involved. So here you have torsional spring, you have rotary damper, okay, and you have a mass, that is. So here, like your spring and dashpot, this torsional spring itself, or this torsional rotational building block itself, has their own governing equation. If you talk about your torsional spring, so T, that is the torsion, is equal to K theta. Okay, so means the angle which it is rotated or twisted. Then you have your rotary damper. So a rotary damper basically represent a disc which is rotating at a very high speed inside a fluid. Okay, so T is equal to C omega, where omega is angular velocity. You have d theta by dt. Then you have uh, your inertial component, which is T is equal to I alpha, where I is moment of inertia. Okay, and alpha is angular acceleration. So I d square theta by dt square. Okay, so likewise, these are the uh, here this uh, torque is analogous to force. So likewise, we have energy also. Okay, so if you talk about torsional spring, E is equal to half T square by K. Okay, then you have a rotary damper. So here also the damper is used to dissipate the energy. P is equal to C omega square. Then you have mass, that is an inertial component. So here half I omega square. Okay. So basically what you have is, if you consider your mechanical system, so a mechanical system is represented by three building blocks, that is spring. Then you have spring, you have dashpot, third is your mass. Okay, and in mechanical system you have linear or rotational motion involved. Okay, so if you talk about your spring, F is equal to Kx, dashpot, F is equal to Cv, that is C dx by dt, and F is equal to Ma or M dx square by dt square. Okay, so these are force component. If you talk about energy, so half Kx square, here half mv square, and here you have dissipation, that is half CV. Likewise, if you have rotational element, F for spring here is replaced by T, that is K theta. Energy is equal to T square upon K. Okay. Then you have T, that is C omega or C d theta by dt, and you have T, that is I alpha or I d square theta by dt square. Here you have dissipation, that is C omega square, and energy half IV square. So these are the basic building block of any mechanical system. And as I told you, using this using these building blocks, you can develop a whole mechanical system uh, uh, by combining these three building blocks. Okay, and any model is developed by hello. Yeah, any model is developed by combining combination of these building blocks. Okay, and each in a mechatronic system, it generally have mechanical, electrical, fluid, and thermal models, which itself is developed from uh, different building blocks. And today we have covered our first, that is mechanical system. And in mechanical system, we covered three major building blocks, okay, which is spring, dashpot, and mass. Uh, a mechanical system uh, need not to have all these components, but the property these components are representing must be there in a mechanical system. Okay, and the properties are stiffness, uh, inertia, and friction. Okay, so analogous to this, we have uh, developed equations for three building blocks under linear and rotational motion. Okay, and these equations are developed from the basic law of physics, which is Newton law. Okay, so I think this is clear for you guys. If you have any doubt, you can ask. uh, if you have any doubt, please ask.
No doubt, sir.
So let me briefly go through the presentation. Okay, although I will upload it. Yeah. So these are the basic system model. Okay. Is it visible? Slides are. I think I need to change the tab. Now I think it's visible. Huh?
Yes, sir.
Yes, sir.
Yeah. Yeah. So basically, the system model are used to understand the behavior of the system, and in order to understand the behavior of system, uh, we develop mathematical models. Okay, and these mathematical models are based on certain laws of physics. Okay, and these models are created using equation which describe the relationship between input and output parameters. uh, let me tell you that initially this mathematical model are used to represent any system, and we predict the properties, we predict the behavior of the system. And so the basic thing is, first of all, we have to search for a mathematical model equation uh, which uh, very closely relate to the system, and which needs certain understanding of the physical laws. Okay, but nowadays people are optimizing people are utilizing machine learning based methods which are not dependent upon this physical law. Basically, with the help of the data, system learns and mimic the behavior of the system. Okay, so then a system model can be mechanical, electrical, thermal, and fluid. Okay, and which is developed by various building blocks. Okay, so as I was telling you that these physical laws, you need a close understanding of this, and also you need a equation which can represent a system very closely. So nowadays you can use a machine learning model. So probably in next class I will show you that how that we have used a model which is dependent on the data rather than a direct ML based model or direct physical laws. Okay. So each building block represent a single property. Okay, if you consider an electric circuit, you have resistor, capacitor, and each of these building block are representing its own properties. Okay, so combining all these building block, you can obtain a input-output relationship. Okay, and the developed system is called lumped parameter system. Okay, uh, so if you talk about mechanical system, you have this three as we have covered. Okay, so so these are the representation and input output model you can see. Okay, and likewise you have rotational component, and this is the comparison uh, in linear and rotational system with the translation linear system, like we are representing force energy, and for rotational system likewise. Okay, so in next class we will develop few mechanical system, and then we will jump to your electrical system. Okay, and anyhow yeah, so anyhow this machine learning is also a part of your syllabus. You have a brief introduction of machine learning in last. Okay, so what I'll do, I'll take one class on machine learning. Okay, uh, and where I will show you some of my work where we have developed certain techniques to predict the properties of the welded and additive manufactured part, and these are not totally dependent upon the laws of physics. So we haven't searched for any equation which can totally represent. With the help of data, we are able to do that. Okay, so this will help you to understand this in more better way. Hello, Utkarsh. Utkarsh, and also Kalyan, I request all of you to join through your official NIT Warangal email ID, because few of you are joining from your phone, and in your phone you have your Google account login. So that's why you are not able to join through. Uh, every time it will ask for the permission. Okay, so that you have to take care of. Okay.
Yes, sir. From next class onwards, we'll with the
So
student.
you haven't faced this problem in other class?
No, sir. Like, uh, no. They will give permission of all, so faculty will.
Uh, okay, I don't know from where we can assign that. Otherwise, I would have uh, done that already. Okay. So I think we can end our class. Okay.
Okay.
Utkarsh, to this permission issue and all this now, I'm constantly getting notification, and it was bothering me during the class. So next time onward, we have to sort it out. So Kalyan, you kindly take care of that option from where we can do that. Okay, so that
Yes, sir.
next in next class we will not face a problem. Okay. So we can end our class here. So sorry for your inconvenience because I am not very much familiar with the WebEx platform. Okay. So from next time onward, you will not face this problem. Okay. So okay, we can end our session here. अरे उत्कर्ष तुम इतना बार आना जाना कर रहे थे, इतना नोटिफिकेशन से इतना प्रॉब्लम हो रहा था, ऐसे बार बार मत घूमने के जाया करो भाई. Okay, those who want to leave, they can leave. If somebody want to discuss anything, they can discuss. Otherwise, I will end the class.
Yes, sir.
Thank you, sir.
Yeah, thank you.